Welcome to another CCNA security class. Today we have very interesting topic also for discussion which we choose from CCNA security exam blueprint. Today we will discuss the network topologies. There exists a number of network topologies that depend on the size and the type of each organization. Sub-organization maybe have all using all these network topologies in their networks, and some maybe is missing if they have the small organizations, like they have only the head office, so maybe they not have the WAN, and they not have the small office and home office, and if they are located only at one location. So maybe this topologies actually it's vary from means depend upon the size of the organizations and depend upon the activity of the organization. If they have business and their business is spread at a wide area network, and they have presence over different locations or geographical, which is separated from the head office. Okay, so maybe they have the all these topologies, but it's depend upon the size of the network. So it's depend upon the organization where you are working. So if you are working in the organization which have the presence in the different areas, so you will see all these topologies in your network. But if you are working in a small organization, or maybe it's a big organization but it's only have one office, okay, it's not have any geographical presence over the other areas. So it's depend upon the size. We will discuss all these network topologies one by one. So the first one, which is a very important technology that every organization have, is known as the campus area network. What is actually campus area network? Campus area network is a is a network topologies that used to provide the connectivity, data, and applications and services to the end user of an organization. Okay, so here we see that this is now our campus area network, and it also have contains module for each building, and this module is also connected to the WAN zone, and the module connected to the WAN zone also, if sorry, data zones. Okay, I think this color is good. No, I will choose another color because here I already linked this one with red one. Yes, this one. So we have different modules that connecting to the other zones. Okay, other network topologies designs. If we have WANs, like for example this one. So, and here's the campus. This is overall picture of the campus area network. Okay, so it's providing, here we are providing different access, connectivity, application, and data services to the end user. So maybe end users, some end user connected to this one, or maybe end user connected to this. Here we have PCs, which is connected end user PC. So this is connected to this one, to the access layer of the campus area network, and access layer after the distribution of the campus, and the distributions later on the core connected to the core one. So we designed we define these layers, different layers. Okay, and we design our network according to these layers. All these layers are divided according to their are designed according to their roles and the job which these layers perform in day-to-day activities. For example, in the core layer we have different tasks in the core layer. So normally core layer is very fast. Okay, and we are running in the core layers, routing. Okay, layer 3 core layer is normally running at layer 3. So we have routing here, means if any links go fails, this link will be other, what will be the other links, how will be the convergence, what's the how we will use this backup link. So normally in the core layers we have dual devices, means one device, for example this one is we have backup for this one. Not actually we can say backup, because we are using both these devices as active. So we maybe some traffic is using this path and some traffic is using this path. So it's depend upon our configurations. Actually, this topic not we will discuss in the security, because this is network area. So network administrator know that how they will move their traffic. But this is the core layer. Okay, so core layer actually it's connected to all of the network modules. For example, we have data center. So core layer also connected to the aggregation of the data center. Core layer also connected to the WAN aggregation. Core layer also connected if we have here the internet edge. Okay, if we have internet edge here, so it's connected to internet edge also. If we have the user campus switches, aggregation switches, distribution switches, also connected to the core layer. So core layer actually performing as a hub means all the traffic passing should pass the core layer. So core layer switches normally have high capacity, and they have blade technologies inside that once they are performing layer 3 tasks, all the layer 3 tasks in the core layer. So this is the core, and now if we discuss the distributions layer here, distributions layer also have sometimes layer 3, sometimes layer 2. We are using the layer 2 links from access to towards the distribution. Sometimes we have this link maybe layer 3, but all this link is layer 3, which is in the red. Okay, if you see that link, this is the layer 3 link. But here we have see, here we are using layer 3, here we are using layer 2. So it's depend upon the administrator that how he configures his network. Okay, but in aggregation we can use the quality of service. We are using the different applying different access lists, that which traffic will be passed the aggregation layer and which traffic will be denied. So this is the campus area network. It means connecting different LANs. Okay, it's maybe in the same buildings, or maybe it's different buildings but in the same geographical area. So we have in the same area, maybe we have like for example our university, if we are the managing the university network, or if we are somewhere we managing the college network. So maybe it's different buildings inside the university, but this is one area, one campus area network. So same if you have big enterprise, and that enterprise have 2 or 3 buildings, but all buildings in the same in the same geographical area, uh, then it's a one campus area network. So keep in mind that campus area network actually it's in the same geographical area. So if we are moving from one area to another area, then it's not will be a campus area network. It's maybe then WAN wide area network. So we will discuss next one. Yes, this one is the wide area network. So as we defined in the previous slide, that for example, this is our one campus. Okay, this is maybe our head office. I think this is very small. No problem. Normally head office size is the largest, so I should must I take this picture over from internet. So okay, this is for example our head office, and we have different branches all over the world. We have our presence all over the world. So we are connecting these different branches. But now this the distance between between head office and branches, it's maybe miles. It's maybe hundreds and thousands miles. Maybe we have one branch in the one area of the in the east of the world. Okay, maybe in Japan, like, and other one is in the west of the world, like we have some branch in the Europe or in the America, North America, South America, whatever. So it's connecting all the world actually. If we see the wide, the cloud connectivity or the WAN area network, WAN is by its definition, if you see this one, the wide area network. Okay, so geographical we have move our business to the different locations. So we have presence in the different locations in the world. So we are connecting all these locations, all these dots which we see here. This is our office. Okay, so we are connecting all this office to our head office. So we will connect over the wide area network, and this wide area network, this WAN connectivity may be via MPLS VPN. Here maybe we have our MPLS VPN cloud. Okay, sorry, or we are using we are using maybe some like nowadays hybrid technology, that is a combination of the internet, okay, and the MPLS VPN. It's very hot cake nowadays in the industry. What's happened to my friend? Okay, maybe we have here internet. So, yes, so it's a combination, like we will configure now in the next classes maybe, and we will discuss about this one in the DMVPN technology. So DMVPN technology actually it's maybe we are using the internet technology, and we are using the IWAN, intelligent WAN, which is the combination of the both internet and MPLS VPN, because MPLS VPN actually give us a huge cost. Okay, if we run the MPLS VPN operation, so it will be huge cost, and we are the link which we take from the ISP is very costly. So normally internet is cheaper as compared to MPLS VPN. So now organizations moving to the smart solution, and the internet is very stable nowadays. If we see, uh, 10 years back. Now, if we compare the 10 years back internet and nowadays 2016 internet, so now internet is very fast and we are running the gigabits traffic over the internet. Okay, we have gigabit link towards the internet. So internet is doing the in the very, that means internet connectivity is very fast, reliable, and cheaper as compared to MPLS VPN. So different branches, maybe connections through, some branches have MPLS VPN, some branches have internet connectivity. So it's depend upon the technology which we are using in our organization. But overall, the wide area network or the cloud means we are using different technologies. We are connecting different areas or different campus. Okay, using WAN links. It's maybe MPLS VPN or internet, whatever. This is wide area network. So overall, this picture is making the wide area network. Okay, wide area network. Keep in mind that geographically separated from one location to other locations. Okay. The next one is the data center. What is data center means? As we see that we have some servers. Okay, we are using some Active Directory DHCP server, DNS server. We are using some our ERP servers, and all is located in the one location. Okay, so this server connected to the server core, server aggregation layer, and after the aggregation layer, as I mentioned in the start, that all layers is connected to the core layer. Okay, so data centers that provide the services to the end users. Okay, data centers have all the servers which providing the services. For example, maybe we have ERP server. Okay, ERP server. So ERP server also will exist in the data center. We have our AD server, means Active Directory server. We have DNS server, different DNS server. We have DHCP, different DHCP server. So all these servers, which is providing the services to the users, to the end users, that are located in the one area, and that area is known as the data center. Okay, that network is known as the data center network. So data center network is normally different as compared to the normal campus area network. For example, in the campus area network, we use the catalyst switches. Okay, that is connected to. If I move the previous slide, this one, yes. Here, that the campus area network. So the switches, sorry, which is used in the campus area network, that is the catalyst. Okay, but the switches which is used in the data center. Okay, that not normally catalyst, because catalyst only provide now we have new technology and new switches from Cisco. If we see from Cisco point of view, we used Nexus switches. Okay, Nexus, what's happening? Nexus switches in the catalyst. So maybe this is our fabric extender. Okay, and this is our the main Nexus switches. Here we have extenders of this one. So Nexus is fast. Okay, have more capabilities for data processing as compared to the normal catalyst switches. We have 2960, so 3750, that one like 6500 series. So that's no more exist. Maybe in some organizations still using the catalyst switches that have not have enough budget, because Nexus is little bit costly, not so much. It's also, but many organizations, you can say 70% or 80% organization, big organizations, or 90% maybe, that using the Nexus technology in their data center, because Nexus give us the also fast data processing, as well as it give us some unique features which we cannot get over the normal catalyst switches. Like we can run the fiber FC fiber channel over Ethernet using Nexus switches. It's another topic for discussion. We will not discuss in the security. So data center overall means where we have servers, the room where we have servers. Okay, and that server is connected to the aggregation layer of the data center, and then aggregation is connected to the core. And, so we will discuss if in our next classes that how we can increase the security of all these zones, all these different network topologies. For example, we have campus area network. So in campus area network, we have different security. Okay, so according to the users, and because now users have different running different applications, So as per their applications, we will use different security parameters. We will use different firewalls, okay, which is especially designed for the user area, for the campus area network. If we move to the WAN, so WAN is a different network. So now we are connecting to the world, okay, maybe via MPLS VPNs or internet VPN. So we have the firewall which we choose for the WAN wide area network. That's also different from the campus area network, okay. Now, if we see the data centers also, data centers, the security point of view, we will design the different as compared to the campus. So we have different devices in the campus area network. So all this actually it's different, means it's depend upon uh, the network which we are, what type of the network, what's the nature of the network, what's the nature of the network. If the data center, the processing, we require the security devices also which have high processing, okay, which we can, with the high throughputs. We cannot implement here some firewall which have only some MB throughputs, and so we require high device which is as according to the size of the network, or according to the size of the data centers. Okay, we will discuss in the coming classes. The next one is the small office or the home office. As we speak, that WAN is the wide area network, is connecting our different branches, okay, and that branches may be the branch office, or maybe it's a home office, some users working from his home. So we are also providing connectivity. So maybe that link is internet link, okay. This link is internet link, and that link is MPLS VPN, whatever. It's depend upon the organizations how they design their IT web wide area network. So, but the overall purpose of this one, from security point of view, that we will use how we will secure our network, because now it's connecting to the WAN, and WAN here maybe if we are connecting to maybe some other organization also connected to the WAN. If we take the link, some links from the ISP, and that ISP is not only dedicated for us, okay, definitely this ISP giving services to the other companies also. So we will design that when our traffic is leaving our areas, our boundaries, so that traffic should be secure, okay, when it's entering to the WAN wide area network, or the MPLS cloud, or internet cloud, whatever cloud it's maybe it's connected to the internet. That may be connected to here, internet cloud, and internet cloud from after then it's connected to our head office. So it's different. It's small office, home office, and here maybe we have routers. This is ISA router, and that router is connected to single switch. Okay, and that single switch is connected to wireless controller. So in the small offices, we have also different security. Okay, normally it's because it's not a huge network. It's only few users there. Maybe 100 users we have there, or maybe less than. Maybe we have from 5 or 10 users. It's depend upon the size. 2 users, 3 users. Okay, normally in home office only we have 1 user or 2 users that are working from home. Okay, and we declared their home as office, and wide area. I like to work from home, but as I think IT security guy can work. What do you think? Give me the answer in the forum, that security guys can work from their home or not. Okay. Next one is the, as we see it say in the previous slide, the virtual environment security. Virtual environments now exist, I think, around about 99.99% in every environment, in every organization. But still, some companies still are believing at the physical world. They not believe at the virtual world. In 2016, I will give you the one example. Okay, I heard about one bank. Honestly, I not see that one, but I heard from strong sources that they are running their network over physical network, and they have thousand servers maybe, and huge building is where they are managing their data center, and all if you enter in the, when my friend enters in the data center, and he see it's very noisy environment actually, and still they are believing over the physical. I don't know why they don't move to the virtual environment, but it's a famous bank in one of the Arab countries, okay, and that provide still they are over physical network. Virtual network is giving us the more flexibility as compared to the physical network. Okay, if you want to run some applications, and if you have physical network, then maybe you will ask for the server, and that server from means you will take approval from different departments in your company, and after this will be and go to the financial and blah blah. It's giving it's taking a lot of times there to give you one server. But now virtual environment give us the flexibility which we not find in the physical. Okay, so without taking permission from the financial departments or the purchasing departments, we just put a simple request towards the IT who is managing the virtual environment, and just after and maybe 5 minutes we get the servers ready. Okay, and we can run these applications if we are the developer, or if we want to develop some application and we want to make test environments, whatever. So virtual environment give us the flexibility as well as unique features which we cannot get physical environment. But also if we move into the virtual environment, we also should focus at the security, that because if we gaining something, maybe we are losing something. Okay, the physical, if we have the one physical server, okay, that physical server is connected to switches, and that we already have this area security. But what's about if we are now virtualizing this server? Okay, so inside this server now maybe we are using different servers. I will make a big picture and clear picture. So yes, this one. We have one physical server, okay, and that's connected to switch here. We make sure that this link is going through firewall, and we are uh, monitoring this traffic, and we have some access list over this one. We have deny and permit rules, and that finally we are watching this traffic, that what type of traffic coming, and communication from this server towards these servers or from these servers. But if we are now virtualizing this server, okay, till this moment this is physical, okay, so we make sure that this is secure. Here's the plus point in the physical network. But if we are virtualizing this network, this servers, okay, and I'm the sorry, this one, like, so this is now server A, this is server B, this is server C, and B and E, and that's a little bit larger, big server. Okay, I will make here Z. Okay, so A to Z. We have different servers in this physical server. So we virtualize now the environment. But as we virtualized, okay, if we see now, so from one VM to other VM, maybe someone have access to this VM. Okay. Before we see that, we should make sure that only this link should be strong, secure, because this we have only one servers here before. But now when we virtualize these servers, then this server maybe not maybe sure this server have different host different servers. So here from this server someone have access to this servers. Okay, it's have access from this server to this server. Traffic between these servers, we should make sure that this traffic also secure. So virtualization that's coming from with the good features as well as it's with the new challenges also. So we should make sure that the challenges which is coming from the virtual environment, we should overcome these challenges, and we should take some solid steps to make sure that the security of the virtual environment for virtual environment is very strong. Okay, because now it's our data center maybe 99.99% or 100% is running over virtual environment. Okay, so we cannot compromise the virtual environment security. We should make sure that new technologies coming. If you heard about the SDN NSX technology, NSX also is giving the virtual environment security. It's putting firewalls at here. I will not talk about NSX because this class is dedicated for Cisco, so it's not fair with Cisco that we are using NSX technology. But we can also use the ASA. Also have ASA virtual VSA, virtual ASA. Okay, virtual ASA is giving us the features. Okay, and we can virtualize our firewalls for a virtual environment. Okay, so that can give the security to the virtual zones or the virtual area network, virtual environment. So overall, this means we should be focused to the all zones, and we should take some strong steps. And according to the nature of the zone, the nature of the traffic, campus area network, different technology we will use, different firewall we will use, and different security parameters we will use. For data center, we will use different parameters. For WAN, for small office, home office, for the virtual environment, for the cloud computing. So overall means we have different steps, but when we make or we connect all these dots together, okay, then we can say that all these we should make sure that all dots should be secure. Okay, so I hope this class will be very informative for you. Thank you for watching. If you require any further information, you can visit www.readvirtual.com. Thank you very much, and